Welcome to Geometry Notes 2.1. So Unit 2 is a really interesting unit in geometry. It's actually one of my favorite units because it's very, very weird. And you know I like the weird. Um, there's a lot of logic and reasoning and writing, and there's not a whole ton of what you would consider pure math going on. So it's kind of fun and different. And some of you might really like it, and others of you might not like it at all. And a lot of that has to do with how good you are at logic. Let's start off by using inductive reasoning. So we're given some patterns here, and we need to use inductive reasoning to complete the pattern that we're given. So let's look at this first pattern. Okay, I start off with 1, and then 1/4, 1/9, 1/16, 1/25, 1/36. What do you think comes next? All right, if you said 1/49, you're right, which means that our next term should be 1/64. The one after that should be 1/81, and we will end up with 1/100. So sometimes it's a good idea to see if you can figure out what the rule is. And if I think about it like this, if I put our first one over 1, then what's going on is if this is my first term and this is my second term and this is my third term and so on, then what I have is I have the reciprocal, so 1 over my term number squared, because this is 1 squared and this is 2 squared and this is 3 squared and so on. Well, given that pattern, let's look at this next one. So again, I have 1, or 1/1, 1/8, 1/27. What do you think comes next? All right, well, 1/64 is what comes next, and then after that, 1/125, and after that, 1/216. Did you get those? These ones are just a tiny bit harder. It has to do with whether or not you know your cubes. We're still talking about the term number, right? 1, 2, 3, and so on, and we're still talking about the reciprocal, but this time what I'm doing is I am cubing the term number. So 8 is 2 cubed, 27 is 3 cubed, 64 is 4 cubed, and so on. All right, looking at these, I'm actually not going to do them with you. I'm going to let you do them on your own, and we will talk about them in the notes check. So I said that we were doing inductive reasoning, but what is inductive reasoning based on what we just did? Well, it's a type of reasoning that looks for a pattern in order to reach a conclusion. On the previous page, we looked at what was going on with each of those numbers and then figured out what should come next. And we call that conclusion a conjecture. So a conjecture is the conclusion reached by inductive reasoning. It's unproven, and it's based on observations. And since it's unproven, if we can find a counterexample, then we can prove that our conjecture is false. A counterexample is something as simple as a specific case that proves a conjecture is false. For example, if I look around my classroom and I see that all the kids in the front row are wearing flip-flops, then I would look at that pattern and I would reach the conjecture that if you are a student in my class, you wear flip-flops. Well, someone in the second row raises their hand and they say, I have on Toms. That person is my counterexample. That is a specific case used to prove that the conjecture was false. And it needs to meet the first part. If you are a student in my class, well, the person in the second row is a student in my class, but it proves the second part of it false, which is not flip-flops, but Toms. And besides footwear, one of the ways inductive reasoning is very helpful is that anything that has a pattern to it, we can make a conjecture about what happens. For example, standardized tests are super fond of giving you problems like, what is the last digit of 2 to the 81st power? Well, if you try to type that into your calculator, it's too many digits, and so your calculator is going to put it into scientific notation, and then you won't know what the last digit is because it'll give it to you as some small number times 10 to a power. But if we look at what happens when we raise 2 to the first and 2 to the second and 2 to the third and so on, we can start to maybe see a pattern happen. And if I look here, I get 2, 4, 8, 16, and then all of a sudden at 2 to the fifth, it starts over at 32nd. So that ones digit is the same as this. So 2 to the fifth equals 32. 2 to the sixth, I'm just multiplying by 2 again, equals 64. So now I've got my ones digits the same again. 2 to the seventh equals 128. And 2 to the eighth equals 256. So by continuing the pattern one more time, I have concluded that this 2, this 4, this 8, and this 6 repeat. 2, 4, 8, 6. So I know that every four digits, my pattern repeats. So if I want to know what 2 to the 81st power is, I just take that 81 and divide by the 4, and I wind up with 20. So the pattern happens 20 times with a remainder of 1, which means that it's going to be have the same ones digit as this first iteration right here. So the last digit of 2 to the 81 is a 2. Now you try it. What's the last digit of 3 to the 38th power? Pause the video and see if you can figure it out. Okay, well, you know that 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, and 3 to the fourth power is 81. If I take 81 and I multiply it by 3 again, 1 times 3 is going to give me 3. So this starts to repeat again after 4. And that means my repeat for this is also 4. So I take 38 and I divide it by 4. And let me see, 4 goes into 38 9 times, and then it has a remainder of 2. So I'm talking about the second iteration, which means that 3 to the 38th power must have a final digit of 9. Not so bad. What do you think? Do you always divide by 4? Well, let's talk about this case right here, 6 to the 39th. Let me see. 6 to the first power is 6. 6 to the second power is 36. Guess what? They all end in 6. So I think that answers my question right away. No, you don't always divide by 4. What about 5s? Let me see. 5 to the first is 5. 5 to the second is 25. Again, it's always going to end in 5. So can you think of any other numbers that are exactly like 6 and 5? And also, what numbers are going to repeat after 2 places? Why don't you think about these, and you can answer those questions in the notes check. This concludes our lesson on inductive logic, inductive reasoning. I will see you in class tomorrow. Come prepared to use your noggin and identify some patterns. It's super fun for me. I hope it's fun for you. Thanks.